Good day, class. So in this lecture video, I will be discussing projectiles launched horizontally. So this is the second type of projectiles. The first one we discussed in class was about a projectile launched at an angle. This is the second type. So here in this problem, we have a movie stunt driver on a motorcycle speeds horizontally off a 70-meter high cliff. As you can see, that is this height. And then, how fast must the motorcycle leave the cliff top to land on level ground below? 90 meters from the base of the cliff, where the cameras are. Ignore air resistance. So this is the horizontal distance and the vertical distance. And what's asked in the problem is the horizontal velocity of the stunt driver just before it leaves or upon leaving the top of the cliff. So in this problem, if you will survey the equations that we have, you will notice that the horizontal velocity has two equations. It could be this one or this one. But since we're looking for the initial velocity upon leaving the cliff, we are to use this formula. The problem, however, is that this equation requires the value of time. And in the problem, time is not a given variable. So our first goal is to solve for the time variable. And if we will check the equations with time, we have the vertical equations right here. We could use this one or this one. If we are to evaluate the two equations, this is the best equation to use to solve for time. Why? Because in this equation, we will be using gravity, or the 9.8 meters per second squared value, which is always constant. We also have the initial vertical velocity VIY, which in this problem is 0. So at the top of the cliff, the velocity along the y is equivalent to 0 meters per second, or there is no vertical velocity. So it would be convenient to use this equation for this particular problem. So I will just write down some variables that we know. We know the horizontal distance is 90 meters. The vertical distance is 70 meters. And what we're looking for is the horizontal distance. But the problem with this one is that the formula for it requires time. So we need to look for that first. Again, we will be using the equation delta y equals VIY delta t plus 1/2 g delta t squared. We can also write it this way: VIY t plus 1/2 g t squared. Now from this formula, you'll notice that VIY here is equivalent to 0, so you can cancel that one out. Thus, your equation will become delta y equals 1/2 gt squared. Again, this is because VIY is 0. Alright, now that since our equation is a little shorter, we can now derive time. So to derive time, you just have to cross multiply, and you'll have a 2 delta y equals gt squared. And then finally divide by g, and t squared will be equal to 2 delta y over g, and then extract the square root. Thus, our final equation for time is the square root of 2 delta y over g. Now, all you have to do is to substitute the values. So that's the square root of 2 times negative 70 meters. Why negative? Because our origin is at the top of the cliff, so any number, any value below it should be negative. Alright, so times 2 divided by negative 9.8 meters per second squared. This is the value of acceleration due to gravity. If you input this in your calculator, you should get about 3.7796 seconds, or approximately 3.78 seconds. Okay, I just rounded it off to 2 decimal places. Now, what do we do with this value of time? This value will be used to solve for the final horizontal velocity. So let's go back. Let's use that equation. The equation for horizontal velocity will come from delta x equals Vix times t. So you just simply derive a little bit. You need to isolate t. So you will divide the equations by v by t. So you will cancel t, and then your final Vix equation is delta x over t, and you just have to input this, the values. So that's 90 meters divided by 3.78 seconds. You input that in your calcu, that is approximately 23.81 meters per seconds. So this is the horizontal velocity of the person or the driver upon leaving the cliff per seconds. And that's it for this problem. Thank you for listening.